In problem number 3, we want to compute, which is the hard part for me. It means arithmetic. So, in part A, we want to take the dot product of this vector with this vector, a row vector times a column vector. The entries are the dot product will be -2 times -1 plus 1 times 2 plus 3 times -2, which is 2 plus 2 plus -6, which is -2. Now, if we take the dot product of 0, -1, 2 with the same vector, we get 0 times -1 plus -1 times 2 plus 2 times -2, which is 0 plus a -2 plus a -4, which is -6. Now we want to take a matrix times the vector, but I notice that I can partition the matrix into rows, and those rows are exactly the row vectors from A and B. And so I know by partition matrix vector multiplication, the result is going to be a vector of size 2 with entries -2, -6. I didn't even need to do arithmetic. Yay! Okay, here I'm going to have to do arithmetic again because it's the same matrix, but the vector that we're multiplying by is different. So I'm going to again partition and use dot products. I know the answer is a vector of size 2, where the first component is going to be -2 times -3, 6, plus 1 times 2, which is 2, plus 3 times 1, which is 3. So 6 plus 2 plus 3 is 11. The second component is going to be 0 times -3 plus -1 times 2 plus 2 times 1, which is equal to 0. So now for E, I notice I'm doing a matrix multiply, where I'm multiplying a 2 by 3 times a 3 by 2. So the solution is going to be a 2 by 2 matrix. But I notice that the columns of my matrix are actually the vectors from C and D. So that I can save arithmetic again, I'm going to partition my matrix and use matrix multiplication by columns. The solution is going to be this matrix times the first column here will give me the first column of my solution, which I know has to be -2, -6. And the second column of the product is going to be the matrix here times the column vector here, which is 11, 0. So yay, no arithmetic again. I managed that by partitioning and using matrix multiplication by columns.